the Medical AI Podcast.
Welcome to the Medical AI Podcast with me, Dr. Felix Beecher. Strap in for a 30-minute thrill ride of big ideas. A recent study by McKinney and colleagues showed that deep learning AI systems outperformed human radiologists for the detection of breast cancer. Except that this wasn't so recent. This was in fact published in January 2020, over 5 years ago. While AI screening is growing for breast cancer, it still only accounts for around 10 to 20% of routine mammograms. So what's the hold-up in adoption of radiology AI? And how do we get past those roadblocks? Well, with me to discuss this is a giant of the field, the gadfly, the brilliant Professor Paul Chang. Paul, a very, very warm welcome.
Oh, thanks for inviting me, but that's a little bit of a hyperbolic statement.
If anything, Paul, I was understating the matter. You're being very modest.
I think it's more apt to say I'm an old fart with a good BS meter. I think that's kind of the bottom line here.
Well, Paul, for those who haven't heard of you, could you introduce yourself and explain a little bit about what it is that you do?
Sure. I'm a professor and vice chair in the Department of Radiology at the University of Chicago. Clinically, I'm a clinical radiologist, and I'm also vice chair of radiology informatics. So my responsibility is the development and implementation and support of informatics solutions within radiology and the hospital in general, including digital image management and AI applications.
Paul, why don't we start with a consideration of the potential for radiology AI? Could you describe that?
So I'm going to start off being a bit contrarian, and instead of starting with the potential, the technical capability of AI, I generally like to concentrate on the problems we think AI can solve. I like to concentrate on the actual use cases and problems rather than the technology. Whether or not you're a fan of AI or not, it doesn't matter. We desperately need help with something, whether it be AI or magic or something. We are barely hanging on. As I travel around the world and talk to my colleagues, radiology is barely sustainable as it is now. The complexity and size of our image data sets are increasing to the point where existing systems and human radiologists can barely cope. We're spending too much emphasis on time-consuming tasks that are very tedious, that results in quality variability. And I'm not saying it's the primary responsibility for burnout that you're hearing about, that's ubiquitous around the world when it comes to radiology and medicine in general, but I think it's a significant contributor. Our clinical colleagues are increasingly practicing what they call precision medicine. Precision medicine requires precision radiology, and we barely have time just to look at the images. And I think that's the reason why data science approaches such as artificial intelligence are so important. While certainly overhyped, they speak to the fact that we have to significantly change the way we practice radiology. Our existing interaction between our IT systems and humans is suboptimal. And so whether or not you're a fan of artificial intelligence and machine learning, we're going to have some augmentation, some tool to let us, the human knowledge worker, get through the day to improve our patients' care. Because right now we're barely hanging on.
I think it's uncontroversial, though, that the slowness in radiology AI adoption is something that is frequently talked about in the field. But let's think about whether this is a problem at all, or whether it perhaps is a sign that the field is exercising a degree of caution which is entirely appropriate.
Yeah, so one of the misconceptions a lot of people have about healthcare in general, and in radiology in particular, is that we tend to be early adopters of technology. That's actually not the case. It's very difficult to actually look and find an example where healthcare and radiology, even though we use high, very advanced technology, we tend not to be early adopters of that technology when you compare us to other business verticals. Now, the problem is we may not be early adopters. And there are a lot of reasons I don't want to go into right now why we're not early adopters, but we are fanboys. We are very early fanboys. And that's a problem. When you combine being early fanboys and seduced by any sort of transformative technology, and in this case, AI, and that we're not early adopters, we then tend to be subjective to what Gartner calls a hype cycle, where we tend to get seduced by overpromising and whatever transformative technology, whether it be digital imaging, speech recognition, and now AI. We tend to have this peak of inflated expectation. We overpromise. And then we move into the trough of disillusionment where, you lied to us and it doesn't work and all that. Now, a lot of people like to show the Gartner hype cycle, but what people don't understand is, yes, it is true that it takes us longer to adopt technology, but we eventually get there. We eventually learn how to appropriately consume transformative and disruptive technology. AI will be no different. That's the reason why I'm not so much a fan of the Gartner hype cycle, because they tend to hype the trough of disillusionment, and I think we're going through that right now when it comes to AI in radiology. I'm more of a fan of Amara's law, which is Roy Amara's quote in 2006. He basically said, we tend to overestimate the effect of a transformative or disruptive technology in the short run. We tend to, overpromise, underdeliver, but we vastly underestimate the effect in the long run. And I think that's a more sanguine view of disruptive technology. We eventually get there. We eventually learn how to appropriately consume technology. It just takes us a lot longer. And unfortunately, we don't sing the praises of that success. It's only in retrospect. Like I'll use an example that's close to my experience when it comes to digital imaging. The acronym we use in healthcare is PACS, PACS, Picture Archiving Communication Systems. That's why we don't have film anymore. It's all digital. In the early days of that, those of us who were trying to push that and implement that, we were confronted with the exact hype cycle. We overpromised, we underdelivered. Users would threaten to resign, like, we'll never be able to do this. It's going to destroy radiology. It's going to destroy healthcare. Patient care will suffer. Now, fast forward 30 years, when you ask any physician, any radiologist, do you have PACS? Are you digital? They'll shrug their shoulders and go, yeah, so what? It's a commodity. That's what Amara's law says. It's basically we eventually get there, but when we get there, it's no biggie. And I think that's kind of what we're going to go through when it comes to AI.
So, Paul, I think you've put it very, very nicely. Could you also speak to the complexity of the problem, which is another way of saying how difficult is this problem to solve?
Oh, absolutely. And in fact, that's kind of the problem we're going through now, because I do agree that if you actually use the Gartner hype cycle as a model, and again, it's inevitable. We always go through this. I am an advocate. A lot of people accuse me of being a Debbie Downer when it comes to AI. I'm a huge advocate. I think it's going to be a significant contributor to our salvation to address our needs that we talked about before. The issue, though, is it's going to take us a lot longer. We are in the trough of disillusionment, and even though there's a lot of hype, there are significant drivers that are preventing us from adopting AI as efficiently as other business verticals. When you look at other business verticals, they are far ahead of us. They're at least 10 years ahead of us in adopting AI. And I call these four drivers the four horsemen of AI immaturity and disillusionment. These four horsemen, I think, are some of the significant drivers that are limiting our ability to efficiently address AI in a meaningful way and get beyond this trough of disillusionment.
So, Paul, one of the reasons it's such a pleasure speaking to you is because you have thought about these issues so deeply and you have boiled your thinking down into a specific number of problems. Let's dive in. What is the first?
Yeah, so the first horseman actually is the problem and the strength of these newer AI approaches. And that is there's still trust in performance and generalizability. Trust in performance and generalizability is still lacking. To understand that, we have to go into a little bit of detail of how these modern AI approaches work. It's a misconception for people, and it may be a surprise to many people. We've used machine learning AI for decades in radiology, and there's not been a hubbub or huge drama about it. We just never called it AI or machine learning. We called it CAD, computer-assisted diagnosis or detection. We've had that in breast imaging and lung nodule detection for decades. The difference was that form of machine learning required a human being in the front to have a hypothesis, an explicit hypothesis. For instance, I think nodules are round or something like that. And then you went and used statistical methodologies such as feature extraction, segmentation, to extract those features like roundness, for example, and create a tool. And then you would use statistical methods like, I have 1,000 cases of non-nodule cases and 1,000 cases that have nodules. And then you tested to see if your hypothesis, your feature extractor that found roundness, did that correctly distinguish nodules. That model is machine learning. That's a form of AI. We've had it for decades. Now, the reason why it didn't create a lot of hubbub is because you could demonstrate its effectiveness and provide evidence, strong evidence, in two ways. The most important way is you could see what's under the hood. You could actually say, now, why is your algorithm working the way it is? Well, we basically think nodules are round, so our nodule detects roundness. You as a human observer could say, I agree with that. I accept your assumption. That gives me greater confidence in using your tool. And then you could use the statistical analysis. We tested it against thousands of cases, and it works this way, and it has an accuracy of so and so. Now, here's the problem with existing AI. Existing AI models, that's the reason why I love the term deep learning. Deep learning is the word deep is a very apt adjective. It means deep as in very, very compelling, very powerful, but also deep meaning obscure, like deep in the ocean. The way I explain it to my engineers is deep learning and these new advanced AI techniques are when you are too lazy, too stupid, or too impatient, or the problem is too hard to have an a priori model. But what you do have is lots and lots of what we call annotated data. In other words, data that by some other external standard has been identified as having the cancer, for example, or not having the cancer. So you replace that human intuition or that human a priori hypothesis with lots of data because you're either too stupid, too lazy, or the problem is too hard to come up with an a priori hypothesis. Now, because of that, trust in performance I cannot tell you why my algorithm works. Not unlike the early days of machine learning AI, where I could explicitly tell you, yes, our algorithm looks for roundness to look for nodules. I can just say, I don't know how it works because I'm too lazy, too dumb, or the problem is too hard. So I can't give you an a priori understanding of what's under the hood. What I can tell you is we've tested it with many, many cases, and the performance is very good. Now, here's the problem with that. When we just have statistical background, then you have to look at that and say, was the statistical methodology you use trustworthy? We use a term in statistics called overfitting. In other words, are you sure that even though statistically you found that your algorithm is working, can we trust your methodology? And that's one of the fundamental problems we have when it comes to trust, because as we're looking right now, the more we look at these studies, we're seeing more and more evidence of what we call algorithm drift. And what algorithm drift is that algorithm drift is when the performance in the real world doesn't reflect the actual performance that was promised. In fact, it tends to be diminished, and this is adding to this general lack of trust in performance and generalizability.
And it may be worth pointing out that AI drift is something that is inevitable and a fundamental part of AI systems. They are never going to perform as well as they are when they are first trained.
Well, it's actually again, you don't want to. The risk again in this is this a dangerous time. This trough of disillusionment. You don't want to throw out the baby with the bathwater. Yes, what you said is absolutely true. You know, you can't just simply AI algorithms are. It's data science. I hate to say this because it's an oversimplification, but it's nonlinear curve fitting to the nth degree on steroids. And as such, it's a statistical method. You have to continue to feed the AI beast, so to speak. You have to continuously refine your model. And the problem, so this idea of AI drift is not only not unexpected. It is a reflection not of the deficiency in the AI algorithm or in the methodology of AI, but rather how we implement it clinically. We can't just simply train it and then say, here you go, it gets FDA approval, it's going to work. No, because you need to continuously feed it and update it, just like any statistical method. Anybody in any business knows that we've used statistical modeling for forever, right? Here's regression models and all that. We would never say, I'm going to use this regression model and never refine it, never keep updating it. Same thing for AI. Don't throw the baby out with the bathwater. It's not the fault of AI. It's the fault of how we use it now. So algorithm drift is not something that we should be overly concerned about. We should obviously be concerned, but it's not a reflection of a fundamental flaw in the methodology of the algorithm, but rather the flaw in how we use it and not treat it. What we talk about is it's a lack of what we call the AI life cycle. We're not continuing. We don't have the existing infrastructure and methodology to continually feed and update these models in a clinical way that's efficient. So AI drift is not to be scared. You shouldn't be scared about AI drift. It's something to be expected. It reflects more of an immaturity of how we consume AI rather than a deficiency of AI itself.
Okay, Paul, why don't we move on to the second horseman of AI disillusionment? Could you explain what that is?
So the second horseman is that, unfortunately, there's a paucity of truly compelling use cases. The use cases are, they're okay, but they're not killers. They're not the killer use case. For those young people, it's like a Drake song, not a Kendrick Lamar song. And for young people, they'll know what I mean. They're all right, but they're not the real thing. They're not really moving the needle. And that's a huge issue because, again, the use cases that we have, frankly, are being driven by data availability. They're nice to haves, but they're not must haves. And the reason for that is, as I said, AI algorithms require data. So a lot of the AI algorithms are very driven by the fact that we have the data for like lung nodules and breast imaging because we have other large data sets for that. But they're not being driven by truly compelling use case. And that introduces the catch-22 that we're having right now, and one of the big problems and why it's a significant horseman to AI immaturity and disillusionment. And that is the catch-22 is most folks won't invest in the needed IT interoperability capability without a killer use case.
Now, Paul, some people might be a little surprised to hear you say that because we have AI systems for detecting breast cancer, prostate cancer, heart disease, Alzheimer's, you name it. Could you explain a little bit more?
Yeah, the four horsemen is a problematic one. There's still a paucity of truly compelling use cases. In other words, the use cases are, they're nice to haves, but they're not must haves. For our young people in the audience, they're like a Drake song or rap song, not Kendrick Lamar. Our current AI application, now one of the reasons for that is that our current applications are currently driven by data availability, not truly compelling use cases. And that is a catch-22 because most institutions will not invest in the needed IT interoperative capability that is required to build these killer use cases. However, the killer use cases cannot be created without it. So that's the question too. They're not going to invest in data interoperability infrastructure unless you give me the killer use case, but I'm not going to give you the killer use case unless you invest in the infrastructure. It's important to understand that we radiologists, as well as most physicians, we're no longer decision makers when it comes to adopting or paying for these applications, these AI applications, is the C-suite. And the C-suite priorities are very, very clear. And they've always been clear. Return on investment, is it going to make me money? Total cost of ownership, is it going to improve efficiency, save me money? Or regulatory requirement? Do the laws require me to do something? Notice I don't mention quality. Now, it's not that the C-suite doesn't care about quality, but quality is assumed. Quality is assumed that we as physicians will provide that. But when we want to get funding for quality initiatives, they'll struggle with that. They'll say, well, we really need to have something that will improve either ROI or TCO. And when you come under these criteria, current AI applications are significantly challenged because right now they're kind of nice to haves. They're not moving the needle when it comes to the priorities that the C-suite cares about, and that's an issue.
So, Paul, why don't you introduce the third horseman of AI disillusionment?
So the third horseman of AI immaturity and disillusionment is a sticky one. A lot of inertia here. The existing systems that we use day to day, our electronic medical records, our digital imaging systems, the PACS systems that we use, and their associated workflow models, how they are designed to work with human beings, really can't optimally leverage AI. They barely can consume AI now, and this is a problem. And right now, it's problematic not only from a technical issue and a scientific issue. There's also a business problem here, and that is, as you know, we tend to buy our tools from vendors, as we should, and and we trust our vendors. The problem is, right now, our legacy vendors, our electronic medical record vendors, and our PACS vendors, it is in their best interest to control what I call the AI narrative. In other words, and full disclosure, I'm an advisor to both AI startups as well as PACS companies. And I tell them, you better control the AI algorithm, or eventually the AI vendors are going to have you for lunch. It is to the benefit of existing legacy IT vendors to control the AI narrative. What I mean by that is to keep AI as a peripheral to the main thing, that it's just an add-on, that we're the value and AI adds the value, but AI is a peripheral. This severely under-leverages AI potentials. Right now, because AI is being treated as a peripheral, our existing AI models, how we integrate AI algorithms in our existing systems, is very suboptimal. They're used in parallel. In other words, the AI, we send images to the human radiologist. We also send images to the AI agent. They work in parallel. They work separately, asynchronously, and they don't work collaboratively. In other words, the AI agent does its thing and the human does their thing, and then we don't work together in real time. Instead, we meet what I call at the edges. In other words, the AI algorithm may go and say, oh, I see something, so maybe I will let the human know in the beginning, because the legacy PACS vendors only allow the AI algorithm as a peripheral to touch it in the beginning, like maybe send an alert on the work list. That doesn't threaten the AI vendor. It doesn't threaten the PACS vendor. I'll send you an alert. Or maybe I'll let you send a little alert at the end while the human is looking at the image in my PACS. I will pop up a little thing that says, oh, you may want to look at this because I think this might be a cancer. This forcing AI in the corner, this forcing AI as a peripheral, this parallel asynchronous thing where the human and AI don't work together is a problematic problem. And AI will never ever reach its full potential. Humans will never be able to gain if AI is continuously treated as this peripheral add-on. In addition, because it's treated as a peripheral add-on, these existing integration models will not support the necessary AI lifecycle requirements we talked about when we talked about the first horseman, where we need to continuously feed the beast. How do we do that when we put AI in the corner as a adopted stepchild and not treat it as an integral part of our infrastructure? So that's a significant challenge that has a lot of inertia when it comes to the horseman.
So I'm not going to use the word conspiracy, but you're suggesting that there are commercial interests which result in the suppression of the development of AI systems.
I'm not sure I would say conspiracy. I'm a big believer of Christensen's book, Innovator's Dilemma. When they talk about the struggle of how disruptive technology is ultimately consumed by legacy companies, either they die or they reinvent themselves or they acquire the disruptive company or whatever. I think it's more in lines with Christensen's model, and that is existing companies. It's not because of a nefarious scheme, but if you look at Christensen's book, he'll tell you that there are many concepts, not just technical. It's not like the existing vendors are stupid. They don't understand AI. That's far from the truth. Just like in the early days of computers, IBM wasn't stupid. Hell, they invented the IBM personal PC. It's not that these legacy companies are doing some nefarious thing, but rather inherently, as Christensen says in his book, inherently there are structural and relationship issues that preclude them, prevent them from doing the right thing. And that's more in line. I don't think it's this conspiracy, but more that they almost are forced to consume AI as this peripheral because of the drivers that Innovator's Dilemma talks about. I highly recommend that book to folks. It's going to predict how eventually AI is going to be consumed in this horseman.
Could you give us again the title of the book?
Innovator's Dilemma by Christensen.
That brings us very nicely onto the fourth horseman of the AI apocalypse.
Yeah. Not so much apocalypse, just delay, just trophicism. We'll get there eventually. Remember Amara's law? We'll get there eventually. But by the time we get there, everyone will think, who cares? But that's a healthy sign. Yeah, the fourth horseman is another issue. And that's on us, on healthcare institutions. There's a fundamental reason why we're 10 to 20 years behind other business verticals in adopting any transformer technology, whether it be big data or analytics or now AI. Most of us healthcare institutions, we lack the capability to support AI in a scalable and sustainable manner. Two major reasons. One, we lack the necessary data interoperability infrastructure to support AI because our existing infrastructure is EMR-centric, healthcare-centric. We use humans as the integrating agent. Yes, it's true. All our stuff is digital, just like other business verticals. But unlike other business verticals that learned very early on that the data that is persisted in all these databases have to talk to each other, in healthcare, we use humans as the integrating agent. We need, yes, it's all digital, but we need humans to get the pathology information and the lab value and the pathology. The systems don't talk to each other unless they're the EMR. This is a fundamentally problematic infrastructure. It's one of the fundamental reasons why other industries have been able to adopt this. The second institutional issue that we have in healthcare generally is enterprise AI governance and IT governance in general. I would make the argument is still relatively immature, not just with respect to AI, but with respect to how to harmonize the needs of the human knowledge workers, the physicians, healthcare providers, other knowledge workers in the healthcare space, how to address their needs, how to communicate and engage with them, as well as address the needs of IT when it comes to sustainability, security, and scalability. We tend not to view IT as strategically as other business verticals do, and this lack of maturity results in lack of governance maturity as well. And this is another four horsemen that sounds a lot like, who cares, but is actually very, very important and is contributing to our lack of adoption.
So, Paul, could you give a couple of examples of how governance models present blockages for AI development?
Yeah. So a couple of things. When you go to any physician, when you go to every physician, a common, I'll give you two examples. I have never found a physician that says, I love my electronic medical record. Man, I have never found a resident say, Dr. Chang, I wish my Tinder or my social media app worked just like my PACS. I have never, ever heard that. I hear the opposite. Mostly it's in screaming. Why can't that damn PACS or EMR be more intuitive or aware or user friendly? Why can't the UI be more contextually aware, like fill in the blank, whatever social media? My pornography site works better. Some people will say, that's the problem. And so one of the problems when it comes to governance is we tend to have this disconnect between IT. IT is viewed as they, them. And I'm part of IT. I report both to my CIO as well as my chair in radiology. And that attitude is problematic, where we in IT kind of bunker up, and those users, they're so demanding, they're so stupid. They don't understand technology. They don't understand the security issues. Many of these comments are valid, absolutely. But on the other hand, as a user, you don't understand my needs. I'm barely hanging on with your systems that barely understand me. I don't want to use 5 logons. I don't want to be the integrating agent. Why can't you be as seamlessly integrated and contextually aware as my social media applications or whatever I use on my iPhone? So they are both legitimate perspectives. We don't work together. This is what governance is trying to address. When you look at other industries, governance tries to address this. We're not. So to me, that is the glaring example why governance is immature. We still view the two tribes, IT and users, as enemies rather than, partners in this endeavor.
Now, Paul, at this point, listeners may be holding their heads in their hands and thinking that AI development is a hopeless cause and that these problems are intractable. Could you hopefully give us an account of why that is hopefully not the case?
No, remember what we said. We eventually get there. It's just going to take a lot longer. Again, the slope of this trough of disillusionment is predictable, understandable, inevitable. But I'm a long-term. I'm an advocate. I am optimistic. So how do we ascend the slope of enlightenment, right? How do we get up there to appropriate consumption? Well, the analogy I use, I think AI is like having a great Formula One car. Well, at least this season. Next season is going to be crap, but because it's all going to be electrical and all that. But at least last year was the last good Formula One year. Don't you agree? Right? But that Formula One car still needs two things, or else it's just a very expensive but pretty paperweight. It needs gas and it needs roads. Yes. And in this analogy for machine learning AI, gas is data interoperability and the roads is workflow integration. And that requires IT infrastructure. Now, unfortunately, we don't have that, but now it's time to drill for gas and build roads. Now, drilling for gas, data interoperability. Now, as I said before, one of the challenges we have is, unlike other business verticals, our IT infrastructure is very EMR, electronic medical records centric. We don't have this concept of middleware or enterprise service buses or other kinds of architectures that are very familiar in other industries. This concept of service-oriented architecture, I know those are buzzwords, but when you look in other business verticals, without exception, they will have a mechanism where data objects are available and persisted in, now it's JSON, it used to be XML, in consumable objects that can be mashed up for any goal. This is a concept that has started off with things like middleware, service-oriented architecture, micro APIs. It doesn't matter. But the important thing to understand is, without exception, other business verticals, from your pizza shop to the military to your bank to the big boys in the cloud, use this approach. In healthcare, that architecture is extraordinarily rare. I would say at university, it's the first thing I built when I was recruited at University of Chicago, a formal enterprise service bus. We put a typical bus in there. Again, buzzwords, I apologize. But the fundamental thing is what is routine and ubiquitous in other industries is quite rare in our industry. We're going to have to learn. But this is the good thing. This is a good thing. I'm a big believer in intellectual arbitrage. The fact that we in healthcare are 10 years more behind other industries. Normally, when you're in that laggard position, you're dead meat. But no, because we're all laggard in healthcare. This is a wonderful risk mitigation strategy. We don't have to guess what our future is when it comes to data interoperability, best practices, when it comes to architecture. We don't have to guess. Our future is any other industry's past. This is wonderful. It is a wonderful risk. Intellectual arbitrage is a wonderful risk mitigation strategy. So one bit that I could say is take a look, be humble, look at other industries, see what they have done with data interoperability. You'll be amazed at how powerful it is and how much cheaper it is as well. We save money doing this. One recommendation, one practical one, if you're too hesitant to dip your waters in AI now, and that's understandable, hitch your wagon to existing analytics IT initiatives, because the C-suite is a little still gun shy, maybe appropriately so when it comes to pulling the trigger on AI purchases, but they are bought into business intelligence analytics. They understand the power, which is ironic because many of the algorithms that business intelligence and analytics uses are AI deep learning algorithms, but we call it BIA or business intelligence. They're willing to invest. Hospitals today are investing millions in analytics. Hitch your wagon analytics, because that's how you get your gas, your data interoperability, your gas and your roads. Hitch your wagon to existing analytics initiatives, because what is good for BIA is good for AI. When it comes to building roads, workflow integration, we have to convince our partners, our vendors, our PACS vendors, our EMR vendors, that AI cannot just be a peripheral. It has to be integrated to the base of what you're doing. The good news there is you're beginning to see that. You're beginning to see, at least in the radiology space, PACS vendors understand, yeah, we cannot just use AI as an algorithm, as a peripheral. We have to figure out a way to integrate it in there. We have to support the AI life cycle. We have to, and doing that, we can avoid AI drift. We cannot have just static training. We have to have continuous training. This requires deep integration, because at the end of the day, the goal is, optimized human machine interaction where AI is going to help. When it comes to addressing the use cases that are, not so great and all that, well, what we have to do, I think, are two things. We need to understand who's writing the checks, the C-suite priorities. So we have to address low-hanging fruit, and that's productivity and efficiency. And there, my recommendation is to look at a standard industrial engineering concept, and that is look upstream. A lot of us physicians, we tend to be we're spoiled children. I'll admit it. We're the squeaky wheel. Oh, I'm unhappy with my PACS, my EMR, blah, blah, blah. I want AI to help me, blah, blah, blah. Yes, while the greatest perceived value, at least certainly from us, comes from what we do, typically the greatest opportunity for improved efficiency and quality results from using processes that improve upstream processes that happen before the images come to me, before the lab values and pathology reports come to the physician. In other words, in acquisition, in scheduling, there's a lot of stuff that happens before the images come to me. By applying AI there, first of all, it's easier, less prone to drift, less prone to hallucination, and it can, day one, immediately address improvements in efficiency. A good example of that is using deep learning algorithms to improve the efficiency and reduce dramatically the time of acquisition in MR and in PET and in CT, in reconstruction, by embedding the AI algorithms or using AI algorithms agents to improve at the level of acquisition have already addressed improvements in productivity and throughput. So now you have a harmonization of the needs and the priorities of the C-suite to get AI algorithms. So that's one example of a compelling use case, the one that the C-suite cares about. I believe that the application of newer generative AI, the transformer-based large language models, have great efficiency to potential to improve the busy work. We use humans now as very basic natural language processors, because a lot of the stuff that we need to do our workflow orchestrations are trapped in unstructured narratives. By just using LLM, we can drastically improve the efficiency of our humans. So those are just two simple examples of having of looking beyond just what happens to the whiny, spoiled children clinicians and radiologists, but looking throughout the whole cycle to find must-have use cases. Again, to me, to finish off, one of my favorite movies is Fight Club. And what's the first rule of Fight Club? Do you remember?
You do not talk about Fight Club.
AI will be successful when we stop talking about AI. I think we're going to move away from the technical capabilities to real-world solutions. Exploiting our laggard position, intellectual arbitrage, will be a wonderful risk mitigation. But the bottom line is stay calm, folks. We're going to eventually get there. AI is going to really help us. The challenges we have now, the trough of disillusionment, is understandable. These four horsemen can be overcome, and they will. It's just important to understand why they're there and what we need to do to overcome them. But I am, as an old fart with a good BS Peter, I am actually long-term optimistic. We're going to be able to leverage it appropriately. We always have, and we will with AI.
Now, Paul, why don't we turn to the institution which has the most direct responsibility for guiding these issues, and that is the FDA. Could you comment on how far you think the FDA is aware of these kind of issues, how well it is dealing with them, and perhaps something about the recent goings on at the FDA and how you think that might change the outlook for the area?
For a lot of people in my space, the FDA is a very, very convenient punching bag. Say, well, the FDA doesn't understand what we're doing. The way we do FDA approval for these things doesn't make any sense, and it doesn't address for algorithm drift and all that. Now, here's what I said. I have many friends, and I have a lot of colleagues that I really respect in the FDA. I have learned a lot about the FDA over the last several months about what they're doing. They have a very difficult job. The first thing is they understand deeply. They understand AI. They have hired and they have recruited domain experts that understand AI very, very well. They're not stupid. The problem is they are highly constrained by how the FDA works in the United States. They can't just willy-nilly come up with a new way of evaluating and supporting a technology like AI. They have to kind of fit it in existing models. AI is a paradigm change. It's a data-hungry beast that you continue to feed. Well, that's not like a lot of other things that we've had in the past. So it's unfair to blame the FDA to say, well, we have to fit in this regulation, because no one could have anticipated, even those of us in the AI space, what AI needs. So it's an unfair punching bag. So I will tell you this: I absolutely know, talking to FDA folks, that they understand that the existing mechanism is cumbersome, that the existing mechanism doesn't fully recognize the life cycle methodology. They understand, and they're trying to come up with mechanisms that still fit within the existing parameters that they are allowed to use. That's the fundamental challenge that people don't understand about the FDA. I didn't understand it until I actually talked to colleagues that from the FDA to educate me. And it says, people don't understand this. Just because they understand that AI probably needs a new methodology to support its life cycle. The problem is when the FDA comes up with a new regulatory methodology, it requires them to go to Congress to come up with a new law. Wow. In today's environment, that's a challenge. And do you want to open up Pandora's box and say, oh, if we're going to change those laws, let's look at all the other laws we might want to change without touching that third rail? Do you really want that to happen right now in the next few years? I don't know. Maybe you do, maybe you don't. My point is the FDA is too easily used by many people, lay people and people in my space as a punching bag. They understand the issue, but they are highly constrained by what they can do and what they do. And if they want to change it, it's going to require something that could be incredibly disruptive. Be careful what you want for. Be careful what you pray for.
Well, Paul, we've covered a lot and I've really enjoyed the discussion. Thank you so much. It's been an absolute pleasure having you on.
Oh, thank you so much for your kind invitation. Thanks a lot. Take care.
Thanks for listening. Ping me on LinkedIn if you have any ideas on new subjects or guests.